Welcome everyone to Vidyastra quick revision classes. So today we are going to discuss one more important topic on which UPSC is surely going to ask a question in 2025. In 2022 UPSC asked the question on this. The question is related to quantum technologies. UPSC asked the question on qubit and what it is related to. So this year the expected questions can be on the following topics. I will discuss each topic with you. I will break down each topic. Please concentrate. These are a little difficult topics, but very scoring. Okay. So first one is quantum cryptography and second one is quantum key distribution. So both are related. First of all, let us understand what is cryptography. You all use WhatsApp. In WhatsApp, you must have seen there is something like end-to-end encryption. Encryption and cryptography both are related. It simply means that whenever we are sending messages or whenever we are sending something that is meant to be sent by someone, received by other person without interference from any other third party, then we use encryption or cryptography. Okay. Now, thing is, till now we are using cryptography, which now we call as traditional cryptography, and it is simple. And UPSC has asked question on this also. If you remember, in 2020, UPSC asked a question on PKI, public key infrastructure. PKI, what PKI is related to? So public key infrastructure PKI is related to this encryption or telecommunication only. So what is this public key infrastructure and what is private key infrastructure? Let me tell you. When we are sending any message from one person to another, the person who is sending the message encrypts the message using a public key. It is a public key, PUBLIC, public key. And the person who receives the message and decrypts that message using a private key, which only that person has. Okay. And how is this encryption done? This encryption is done using various algorithms like RSA and all. Now, what happens in this encryption is two prime numbers, two very big prime numbers. Prime numbers, 2, 5, 7, 11, 13, all these are prime numbers. So what they do is they multiply two very long prime numbers. Two very long prime numbers are multiplied, and that message is encrypted inside this very long prime multiplication. So anybody who wants to decrypt this message or interfere with this message will have to break down this multiplication. And this multiplication is such that it is easy to multiply, but it is difficult to reverse. Means it is difficult to know which two numbers were multiplied to reach at a certain number, because that number can be 1200 digit long. 1200 digit long. So it becomes very difficult to decrypt this message. It means it is not impossible, but mathematically it takes very long time, even for the supercomputers. But issue is now we have quantum computers, and you already know that quantum computers are really fast. So they can solve that problem also. So there can be a day, let's say in future 2-3 years down the line, when none of our messages will be safe. I'm just assuming. Okay, none of our messages will be same because everything can be decrypted using quantum computers. So we are so to solve that problem, we are moving into quantum cryptography, where we use quantum principles like superposition, entanglement, and quantum interference to create a new type of cryptography. Now, how this cryptography is different is, this is different in the manner that the key, that the private key that we talked about, that key is distributed, means this quantum key distribution means this key is the only thing that is distributed, not the whole message. It is different in the sense. Okay, in this sense it is different. Means now in the traditional cryptography, there is no way to find out whether that key was copied by something else or that that message was decrypted or not. But there is one theorem, one principle in quantum computing, quantum mechanics, no cloning theorem. That is, no qubit can be, no quantum states can be copied. Okay. So if somebody copies that key, we will know. Somebody copies that key, we will know, because if there is any attempt is made to interfere with that message, then we will know. Okay, so now what we do is we do not send the message first, we send the key, means like a test key. So what happens if somebody is interfering that message, so the original message won't be safe, it will be safe. Okay, so again we will send the key. Now if there is no tampering, then the original message will be sent. So this is on which quantum key distribution works and quantum cryptography works. But the issue here is now thing is unbreakable security based on quantum principle. If UPSC says it is unbreakable, just mark it, yes, it is unbreakable. Okay, yes, it is unbreakable. There is no way to break quantum cryptography. Okay, now but issue is it is at a high cost of implementation. Okay, and limited range and high cost of quantum channels, again because both are related. Now this is related to communication. These two topics, quantum cryptography and quantum key distribution, are related to communication. Now let us see three more topics. These three topics are related to computing. This qubit question was there. These three topics are elongation of that qubit topic only. These are three type of qubits: superconducting qubits, neutral atom qubits, photonic quantum computing based, means here we use photons as qubits. Okay, so since UPSC has asked this qubit, it can definitely ask one of these three. Okay, now let us understand. It is simple to understand. In superconducting qubits, what we do is we use superconducting principles. And this term you need to remember. UPSC can ask what this term is related to. Josephson junctions. Josephson junctions is like separating two superconductors by an insulator, and this creates a junction. Okay, so now superconducting circuits, qubits are found by using superconducting circuits that operate at cryogenic temperatures, and they are controlled using microwaves. So let me just tell you what are bits first, then what are qubits, and then superconducting qubits, neutral qubits, and photonic qubits. Now bits, you need to understand is it is simple storing information in the smallest form, 0 or 1. Okay, 0 or 1. If there are 2 bits, then there can be a combination 0 0 0 1 1 0 1 1. Okay, so this is a bigger message. It can mean 0 1 2 or 3. So if we have 3 bits, then then possibilities can be 0 0 0 0 0 0 0 0 1 0 1 1 1 0 0, means all such possibilities which are possible by permutation of 3 digits. Okay, so if we have many bits, so we can actually store an information through these bits. So this is all means everything today works on this principle only, storing information in bits. Like you are downloading a file, you say that this file is 90 MB. This is actually 19 megabytes. 1 byte is equal to 8 bits. So you are actually downloading nothing but 90,000 mega means 1000, byte again 1000. So 90 into 1000 into 1000 bits. You are downloading bits only. Okay. So what the issue thing is now we are moving towards quantum computing. Quantum computing is faster. It uses various principles like superposition, entanglement and all that, which makes it more efficient and faster. So these three are variants of that. Whenever you are using superconducting materials, means whenever you are using low temperatures like 15 this Kelvin, millikelvin, I think this is minus 15 millikelvin. Millikelvin, I don't think this will be millikelvin. Minus 15 millikelvin. Because lowest temperature minus 15 mk. I don't think this will be minus 15. Let me check. Minus 15. 1 second. Yes, this is million, not million Kelvin. This is 1000 of a Kelvin. So this is millikelvin, not minus millikelvin, million Kelvin. Because absolute zero coldest population, the issue was that the coldest temperature possible is already 0 Kelvin. So this cannot be minus 15 millikelvin. This is 15 million, not million, millikelvin. Okay. So this is requires ultra low temperatures. Now again, this susceptible to decoherence noise. You need to remember this, that quantum computing, decoherence and noise are very important. Uh, if there is a question which is talking about various advantages, and it says that one of the disadvantages is that it is susceptible to decoherence and noise, that mark it. Yes, quantum systems are susceptible to decoherence and noise, and this is their very big weakness. Then we talk about neutral atom qubits. Now neutral atom qubits means we are using neutral atoms. Neutral atoms means they do not have any charge, like rubidium, cesium, and we are using optical tweezers or lattices. What are optical tweezers? Optical tweezers means like we use tweezers, uh, like doctors use tweezers to handle delicate organs. Those tweezers are made of like it is like a scissor type. Those tweezers are made of steel, but these tweezers are made of light. So what we are doing is we to switch those qubits, means 0 1 1 0, what we are using is optical, means light. Okay. So this is very important term, Rydberg state mediated dipole interaction. These are complex things, but issue is UPSC doesn't matter for UPSC. If it was in the Hindu or Indian Express, UPSC will just put it. It is not necessary for you to understand. Plus, it is very difficult for me to make you understand also. Okay. So these things you can learn. Now thing is complex Rydberg stability. Now issue is Rydberg state. What we are doing is this Rydberg state is very hyperfine electronic states, excited states. These are susceptible to noise. Okay. But we are definitely working on it. And after superconducting bits, neutral qubits are very important. One of the most important qubits after superconducting qubits. Okay, next is photon quantum computing. Now, one thing you will be confused about is what are these actually, means qubits, and one has photon, other has neutral atom, some has superconducting. Now, we need to understand when we are talking about quantum computing, what we are actually doing is we are dealing with something at subatomic level. Means anything which is below atom in size, and we are using it then we for this computation or communication, then we are calling it quantum technologies. So photon is another subatomic particle. What is photon? Look, light is actually made of photon. Means photon are various packets of light. Light consists of actually multiple packets, millions and millions of packets. Those packets are known as photons. So those photons, again, particles smaller than atoms. So they are subatomic and they are used in quantum computing. Now, why am I not explaining it too much? Because you don't need this much explanation. If you go into too much explanation, that's why I have kept it short. If you go into too much explanation, you will forget everything. You will be just entangled, just like this qubits are entangled. These qubits are entangled in different quantum states. You will be entangled like that only. So you don't have to be look, the question was itself so easy. What is qubit and what is related to? So they can just simple ask what is photonic quantum computing. So you can simply will find that quantum dots are used for photonic generation, and beam splitters and phase shifters for quantum gates. Okay, what are beam splitters and phase shifters? Again, using optical devices for Gates are means like in electronic systems, gates means again gates are created using bits, means passing of information, and gate, or gate, nor gate, all those, these are the gates that it is talking about. Okay, so that much you must know. Other than that, some issues and merits you must know. Room temperature operation. Why we are saying room temperature operation? Because we are comparing with it with superconducting qubits which are operating at minus 15 15 millikelvin. Okay, now difficult to scale due to photon loss and low fidelity. Why we are saying this? Because quantum computing, because requires ultra low temperature subsidy. One of the merits, fast gate operation, high integration potential. We were saying the advantage of superconducting was high integration potential. So that's why we are saying difficult to scale due to photon loss and low fidelity. So UPSC will just put one of these statements and you will have to choose one of them. Naturally suited for communications over long distances. Okay. Now next one, this is again advanced computing. These are very important topic. Quantum annealing, very important. Then we will come to quantum sensors and quantum error correction. What is quantum machine learning? Quantum machine learning, you simple know that machine learning, artificial intelligence, means training the computer systems to solve and to first assimilate large amounts of data, and then using that data to create pattern and a learning process that continues with every each set of data or iterations. So whenever we use quantum principles with machine learning, we use we say we are doing quantum machine learning. Okay, now what is the use of, what is the advantage of this? Faster optimization of large data sets. Machine learning is simply about optimization. Means optimization means finding patterns, creating new ideas, okay, using the various data sets. But in quantum machine learning it becomes more faster, because here we are, rather than using the traditional computing methods, we are using quantum principles. Okay, and one more thing, these words, Grover's search, Shor's code, surface code, these are very important terms. These can simply come as questions. What are this quadratic unconstrained binary optimization, these icing models, these are very important terms. So in this topic, more than you understanding what actually it is, these terms are more important. You just have to have a basic idea which these terms are related to. Okay, now quantum annealing. What is quantum annealing? Quantum annealing is, again, let me explain you. Let's say you are ordering, very simply, you are ordering food from Zomato. So what the system, once you order the food, now what the responsibility of the software is? The responsibility of software is to first find a delivery boy for you. The system will find a delivery boy based on which delivery boy is closest to you. Okay, or which delivery boy has has better chances of delivering food, what is his or her rating is. Okay, after that, once they have found out, they will send directions to delivery boy, and then they will find out the best route which with the delivery boy can reach the restaurant. Okay, then after picking up the food, the best route to reach your home. So this optimization is the rule today. Means for everything we need this kind of optimization, for every purpose, for logistical delivery, for drug development, for everything we need this kind of optimization. So quantum annealing has become a very important concept because of this. Okay, like this here, material science, machine learning, optimization, portfolio optimization. Portfolio means which shares you have to choose, which are going to give the best job scheduling, which what should be done first, what should be done later, so that the best results can be derived. Traffic flow optimization, as I said, in case of the delivery boy, and all that. Now why quantum annealing is means this quantum concept is important here, because it uses a concept called quantum tunneling. Quantum tunneling to find the minimum, the global minimum. Global minimum means, let's just let me tell you, let's say this is This is these are different hills. Okay, so if we talk about this area, this much area, this is the minimum for here. Okay, but if we talk about this area, this much area, this is the minimum for him, for this area. But if I talk about the whole area, then the minimum here is this one. Okay, so what is happening here is we are not interested in finding this or this. Sorry, this or this. We are interested in finding in this one the best, because we want to find the minimum, the global minimum. These are local minimum. This is the local minimum for this area. This is the local minimum for this area. Okay. Now, to give you analogy, what quantum tunneling is, just a simple analogy. Quantum tunneling means the system will just won't have to look here and there. What it will do, it will detect that this is the area which is this the minimum. It is just tunnel through this and reach at this stage. Okay, and will achieve the quantum minimum. So what is this quantum minimum? This is the optimization. This is the final results which we want. Okay, means if we want to find out the best route, that is done through quantum minimum, the minimum. Okay, if we want to find out the minimum resources that we need to use to create a product, or for a drug delivery, developing a drug, or for developing a material, then quantum systems will work, find out the best combination of materials, men, capital, etc., and tell you this, rather than finding the second best or the second best or the third best. They will find the best. Okay, so this is where quantum annealing, concepts like quantum annealing is used. Now this is also important. Quantum sensors. What are quantum sensors? Sensors you already know. Just the importance, the concept of quantum sensors is it uses quantum principles, again superposition, entanglement, and this interference. Now how these concepts help to make this sensor better? First, let me tell you what is superposition. Superposition means this subatomic particle or this qubit can remain in means quantum means they can remain in different positions. That is why we call it superpositions. Means that is they don't have to be in just 0 or 1. They can be anywhere between 0 and 1. So since there are multiple positions, so what we have in sensors, what we need the best data. Okay, and best data is possible if we have different references. So if we have so many references, we can choose which data is the best one. Okay, so that is the superposition. Now entanglement we are talking about. Entanglement means there are two particles. If they are entangled with each other, and let's say his name is x1, and if they are entangled, his name is also x1. So even if they are millions of kilometers apart, they will know that his name, I am x1 and I am also x1. And if let's say this becomes x2, then even if they are million kilometers apart, it will become x2. Means they will remain entangled. They will pair in such a way that any change in this one will result in change in this one. So this will reduce what? This reduces error. This reduces error. So we make better quantum sensors because of these principles. Now we have quantum error detection. Now quantum error detection. In quantum error detection, you just need to know this methods, source code and surface codes. Now let me just tell you how this quantum error correction is done. In case of the issue here is that, as we discussed, there is no cloning theorem. It is not possible to clone any quantum state. So what is done is, the information that we want to protect or make error free, we keep physical clones of that information. And if there is any tampering or any error, we compare it with the physical clones and we remove the error. Okay, so this is about quantum error correction, quantum sensors, quantum annealing, quantum machine learning, photonic quantum computing, neutral quantum atomic qubits, superconducting qubits, quantum key distribution, and quantum cryptography. These are very important topics. If you can solve these problems, definitely you will have an edge. And believe me, UPSC is asking difficult questions. So rather than being complacent and thinking that doing what everybody is doing can get you through UPSC Prelims, that is not the way it works. There are only 180 seats, only 180 seats of for IES, okay, and 5 to 6 lakh students sit in the exam. 180 is a very low number. If you have to be there, you will have to be special. Okay, so keep studying, remain concentrated, keep on revising. Bye, take care.